Hello dears, our next topic is functions and I'm just telling you the technique of the transformation of the graphs. How to do that. I'll start with an easier process, the graph which you know, and I'll just convert that one into the different forms. Okay? You just see how. You know the graph of y equals to log x. Okay, you just see that how this graph is. Okay? It is like this. Getting this or not? So it is a basic graph and it will touch the y-axis at infinite. It will go nearer and nearer to the x-axis, but it will never touch the x-axis. Okay? But log x, then x can never be negative right now. But what about the second case? It is first one is the graph of y equals to log of x. But what about this y is equals to log of mod of x? Now I can put the negative values as well as the positive values. Okay, because if I'm putting a negative value, mod of x will make it positive simultaneously. Okay, so if I'm making it modulus, it will be the reflection of the function with respect to y-axis. So what will be your part? You just see that your original graph was like this, but if I can put the positive values simultaneously, I can put all the negative values also and I'll get the same result in those cases. So my graph will be like this. Okay, but if I want to find out in the third case, now my third graph is y is equals to mod of log x. Means what? It is the transformation of the first case. In fact, if I'm taking the whole modulus, then the negative part must be made positive. You just see how. Okay. When I'm putting the values which are greater than 1, obviously output will be greater than 1. But if I'm taking this as less than 1, then output will be negative. Then this will be transferred above that, the x-axis. Got this or not? So it will be transferred like this. Okay, so the graph of y equals to mod of log x will be like this. Okay, in the fourth case, the graph is y is equals to mod of log of mod x whole mod. Okay, what we have to do, whatever is the negative part in your second graph, we have to make them positive in this case. So how this graph will be, you just see this properly. Positive part and its negative part is made positive. Got this? Similarly, this part and the other part made positive. So your graph will be like this. Clear? Any confusion in this? Okay. Now you just see the next part. What is the next part? That is the fifth part. That is modulus of y equals to log of x whole mod. Sorry, it is modulus of y is equals to simply it is log x. Okay, this mod is not there. Okay, see this. If you take mod on x, then you have to take the reflection of the curve with respect to y-axis. If you're putting mod on the y, then you have to take the reflection of the function with respect to x-axis. So transform you just transform this graph from the first graph. Okay, you have to take the reflection of the graph. You just remove this and reflection of the graph with respect to the x-axis, because we are putting the modulus on y. So when we are putting the modulus on y, we are taking the graph, we are taking the reflection with respect to x-axis rather than the y-axis. And see the sixth part. It is modulus of y is equals to modulus of log x. Okay, now what is the kind of graph this will be? You just see that y is equals to mod of log x. This is the third part, and it is like this. I have to take the image of this with respect to the x-axis. So how it will be? You just see this properly. The original graph was like this, and I have to take the image of this with respect to the x-axis. So it will be like this and this. So the graph of mod of y is equals to mod of log x will be like this. So you just understand two concepts. Whenever we are putting the modulus on x, we have to take the reflection of the graph with respect to y-axis, and whenever we are putting the modulus on y, we have to take the reflection with respect to x-axis. Got this, dears? I think these concepts will be very useful for you. Okay, dears?